So first quiz for our polynomial unit here. Biggest thing at the start of this is going to be in these first 4 problems, recognizing when there is a symbol, plus or minus, in between your sets of parentheses, in between your quantities, because those are the ones where we're just combining like terms. We're not doing anything fancy. So like, for instance, on 1, with that plus there, there's really no need for the parentheses to even be there. I'm just going to start combining like terms right away. So I look through, I'm looking for my largest degree first, and I find it here with my x to the 4th. There's only one of them, so I write that down first. Then I look for my thirds, if there are any, and there are. Watch the signs, those matter. 8 minus 10 would give me a negative 2, x to the 3rd. Again, not messing with the exponents at all. 7x squared, no other squareds. X's, 1x minus 5x is negative 4x. And then finally, to finish off, the plus 1. So that's all I'm going to be doing on these first couple of problems. Now the only change is going to be when I get to number 2, that minus in the middle is going to distribute through to all 3 of those second terms. So on this one, I would recommend rewriting everything with the signs changed on all 3 of these last terms, because that's what the negatives are going to do. So once we do that, now it's just like number 1 was. We're just going to look for where our like terms are. Oh, hold on just a second here. So once we start to put the like terms together, again, we look through. There's my biggest degree. Get that in there first. Got our squareds. Again, we're just adding and subtracting the coefficients on these. Just the single x term. And negative 10 minus 6 is negative 16. So that's all we've got mainly working on that. So as I keep peeking through, I'm looking and I'm going, all right, number 3, we've talked about 2 ways that you can do this. I can do it by distributing the 2x through to all my terms, and then distributing the negative 3 through to all my terms. It'd end up looking something like this, and I'd be able to combine the terms. That's fine. Some of you have shown some interest in just doing a box with these, because it's more of an organizational tool to remember, hey, I'm not going to forget a term this way. Which for me can always be a possible challenge here. So when we start to fill the box, we're multiplying. We multiply coefficients. We add exponents. Same all the way through. Multiply coefficients. Add exponents. Multiply coefficients. No other exponents to add. And then I do the same thing with the bottom row. Multiply coefficients. And there's going to be no exponents to add, so I just have to make sure I'm good with my signs. And once I've done that, the nice thing is going to be, for the most part, this is going to be set up right in standard form order for me. So 6x to the 3rd. There's my x squareds again. No more multiplying. We're just combining like terms. So negative 19x squared. 15 plus 4 is a positive 19x. Minus 6. So we're just kind of working through those a bit. Now, when we get to 4, you've got a choice. Okay, and I'm going to go with the majority here on this one. I'm assuming most of you are going to avoid the pattern for cubes and go to the boxing. Okay, now if you've been working on using the form and you're going to use the cube form, that's a-okay. That's a great thing. It's going to go a little quicker for you. But if not, remember, this just means there's going to be 3 of these. I can't just distribute the cubed and call it good. It won't work. So here, we're going to take these a pair at a time and multiply them out. So here you can FOIL or box it, depending on how you want to go. For those of you that have come up and talked to me, I've seen lots of people boxing, so that's the route I'm going to go here. Again, putting the coefficient in front and the exponent in, not a bad idea, just to remind you with your rules. Multiply coefficients, add exponents. Multiply coefficients, no exponents to add. And I do that. Negative times negative is positive. And I'm going to rewrite this with my like terms combined. Now, I wish I could say that was the end, but it's not. That just took care of these first 2. So now the third one's going to come into play. So we're going to do it sort of like what number 3 looked like. I got my x minus 3 going down the side here, and my new product from the first 2 going across the top. Same rules are going to apply that we just did in the other box. No matter what size they are, the rules are the same. So we're going to multiply coefficients, add exponents. Multiply coefficients, add exponents. Coefficients, multiply coefficients. Just keep multiplying coefficients, because that's all I got left to do at this point. So again, multiply to fill the box. Combine like terms with adding and subtracting once that's done. So no more multiplying once that box is full. And we're ready to rock and roll. Okay, so it's going to be a patience factor. It's going to be a detail factor. I say that a lot in here, but it's very true in this instance. Because there's lots of little places that you can mess this up if you're not being cautious. Okay. So evaluate, okay? Find f of negative 3, which basically just means plug the negative 3 in for x and find the answer. Now, really, I would hope the only thing that could possibly get you in a bind here, which it's not going to in this case, because negative 4 times negative 3 is positive 12, plus 3 is positive 15, and we know whenever you have an absolute value, like we do here, that the answer or the value inside comes out positive. Well, it's already positive, which is a good thing. So negative 2 times 15 is negative 30. Because the negative 2 is outside. It doesn't get to change signs. And I get my solution with that. And then I do the same thing on this next one. Plug each of those in. And you can plug that straight into the calculator if you're not comfortable messing with all the different exponents and negatives and all that stuff. The one thing you've got to remember, though, is I've got to cube this first, then multiply by the negative 2. I'm not multiplying and then cubing. So this, negative 1 cubed, would be negative 1. But negative 1 squared would be positive 1 if I'm trying to just do this on my own. Multiply, times negative is positive. And I can get to my answer. But if you're going to use the calculator, remember, you've got to use parentheses here or your answers won't come out right. You can't just use the multiplication button. It's just something to keep in mind. I can squeeze that in. Yes, I am. Senior class is selling t-shirts for a prom fundraiser. The class is selling the t-shirts for $12.50 each. The shirts cost the senior class $60 for the design print plus $4.50 for each shirt. Write the profit function. Okay, remember, profit function. Okay. Okay, it could be revenue minus expenses, sales minus expenses, however much money I'm taking in, minus how much money I'm spending outward. So, we're selling the t-shirts for $12.50 each. So $12.50 times the number of shirts we're selling. Got to get the variable in there. And then we're going to subtract our expenses, which is $60 plus $4.50 for each shirt. Okay, each normally kind of gives us a clue that X needs to be in there. Parentheses are a must, though. Because I'm not just going to leave it like this, I'm going to simplify it. And that minus, that negative, is going to go to both the 60 and the 450x. And then to finish it up at the end, I would combine my like terms. So 1250 minus 450 would be 8x minus 60. That's where I want you to get to. I want you to simplify. You're like, well, what if I just left it like this? You're going to get half credit. Okay, because I want to make sure you understand the concept that we need to get that through and to be able to combine like terms. So then when we find the profit, that basically just means we're going to plug in this number where the X is. Plug that into my calculator and find out how much money I'm going to make. So that's what we're on the lookout for there. Then we get into our function notation that we were doing earlier this week. Write an expression, state domain restrictions. Okay, remember, domain restrictions is basically going to be all reals except fractions for our purposes, just to kind of get my brain thinking about this a little bit. So I look at the first one here, f plus g of x. Don't worry about the x, okay? That's just a label. So all I'm doing, okay, and I'll do this on the first one. I won't do this on all of them. Okay, this is what this means. It's just saying take the f function, 4x squared, and add the g function, 2x plus 7. Do I have any like terms I have to put together? If the answer is yes, this is when I would do that. But here, x squared, x, 7, there's nothing that's alike. That's all I can do in this case. But I do need to check. Well, what's the difference here? This is multiplying. Okay, so I'm going to have f of x times g of x. You could make a 1x2 box for this if you wanted to. Otherwise, you can just distribute the 4x squared through, multiplying my coefficients, adding my exponents, multiplying my coefficients, no other exponents, not like terms. Keep it simple, keep it simple. But there's a difference between multiplying and a composition. Now again, if you're not comfortable looking at the composition this way, where the O is, you can rewrite it like we had before, and just reminding yourself, oh yeah, I got to do the inner part first. Or if I'm looking at it this way, I'm going to plug the negative 4 into whatever that closest variable is. So 2 jobs here. First job, g of negative 4. What's that mean? It means I take my g function. When I get to x, I replace it with what's in the parentheses. Negative 8 plus 7 is negative 1. But that's not the final answer. Because now that I took care of this part, now I take that answer and I plug it into my last function. So f of negative 1. Here's my f function. So 4 times negative 1 squared. Be cautious. We talked about this up above. Square the negative 1 first, because that's what order of operations tells me, then multiply by 4. So negative 1 squared would be 1 times 4 is 4. Now I'm done. Always going to be a 2-step process when you're doing compositions. You've got to work through that. And then finally, we're dividing f of x and g of x. So f of x, x squared over g of x, 2x plus 7. Do not cancel. The only way I could cancel 2x plus 7 is if I have the identical thing up here, and I don't. So that one's done, but when we have a fraction, we can't have 0 in the denominator. So there's a restriction I have to write on this one. So 2x plus 7 can't equal 0. And I actually have to find the x value. I can't just write that. So I'd minus my 7. And I'd divide by 2. So my restriction here is I can have all reals except for that one number. Okay, and I've got to find what that number is when I've got a fraction like this. Anytime there's a variable in a denominator, we got to knock that sucker out. But again, if you've been doing these along as we've been doing them, you've seen this before, so it should just be kind of like, oh yeah, those type of moments. If these are like, I don't remember this ever in my life, it's not quite so good. Okay. One more thing with our power functions here. What is, with f of x and g of x, what is f minus g of 2? 2 ways you could tackle it. You could do f minus g, put together the like terms, then plug in the 2. Or you could, since I have a value here, I could do it this way. You're like, okay, well, what would that look like? Well, f of 2 would be 4 times 2 squared minus 2. I'm just plugging in the 2, each place where the x is. And then I could simplify this. 2 squared is 4. Times 4 would be 16 minus 2. So my f of 2 would be 14. But then I'm going to subtract g of 2. So I'm going to plug 2 in here. So 2 minus 8, which is negative 6. And I do 14 minus negative 6. When I minus a negative, that becomes plus. Okay? Now, if doing it that way, you're like, okay, too many numbers working, that's going to drive me nuts. Confused. Hashtag. Okay, if that's going to get you, here's our other option, because I like giving you options. If we did f minus g first, now if you liked the first way, just leave it that way. F minus g. Okay, I'm not going to deal with the number until the very end if I do it this way. I could distribute my negative. Whoops. Yeah, that's right. Combine my like terms. And at this point, once I'm done, I would plug the 2 in. So it would be 4 times 2 squared minus 2 times 2 plus 8. And this way, I'm only actually dealing with the numbers for one step. 2 squared is 4 times 4 would be 16 minus 4 plus 8, which is also 20. They both get me to the right spot. It's just what you're more comfortable with. It's the nice thing about when we have a number here instead of x. If it's x, this is my only option. If I have a number, I have choices. And that's going to be true in 13 and 14 as well. So here, p times q of 8. Okay, now here I'm going to tell you. Plugging in the number right away is very much the easier option. So I'd go that way. I take my p function, I plug in 8. I take my q function, I plug in 8. And then I'm going to solve them each separately, and at the end I'm going to multiply them together. 3 times 8 is 24, minus 6 is 18. The absolute value of 18 is 18. Over here again, calculator is fine if you want to. 8 squared is 64 times 2 is 128 minus 3. Ooh, that's going to be a big number. Is 125. I know I could do it in my head, but I don't want to mess this up when we're working on a preview. So we can get some kind of large numbers here. And then our last one is one more composition. Again, if I want to rewrite it, I can feel free. I'm going to do p of negative 3 first. There's my p. Again, take your time. 3 times negative 3 is negative 9. Minus 6 is negative 15. And we know when the absolute value of a negative is taken, we get a positive out. So that's my p of 3 value. Okay, but that's just this first part. Okay, just that inner part. Now I'm going to take that value and plug it into q. Here's my q. 2 times 15 squared minus 3. 15 squared is 225 times 2 is 450 minus 3. And again, this whole thing could just be typed into the calculator. That's fine. Not a big deal. So this is going to start leading us towards our one other issue here, thing from this past week. Okay, our end behavior, our domain, and our range. And so when we're looking at these, remember, we're doing a sketch, but we want to be as accurate as we can. Just because for end behavior, it may not be a big deal. For our range, it could be, though. So as we're working through these, we'll let the calculator help us out here a bit. So negative x squared plus 5. Okay, we'll take a look at the picture first. Parabola open and down. Okay. Get me some values to work with. And typically, I'm going to take every single one I think basically is going to fit on my graph. And we're going to get those plotted on here. So once I get those up, domain is the layup question. Nobody should miss that on any of these. The domain's always the same. My range, though. Remember, my range is my y values from bottom to top. Well, it's going down forever. Okay, down forever, I know that part. Top, though, it doesn't go up forever. Here is my highest point that my graph gets to, and it's y, so 1, 2, 3, 4, 5. And I close that off. End behavior. Remember, my x's, I don't have to think about that. They're always going to be the same. One's to negative infinity, one's to positive. If I want to put that on my graph to kind of help remind me of that, maybe I do it with my y-axis too when I start to look at my arrows. So remember, when we're doing this, think in English. X is going to the left towards negative infinity. I find my left arrow, and I just pay attention to what direction it's going. It's going down. It's going towards negative infinity. And then I do the same thing for my other x. Okay, positive infinity, we're heading to the right. Find the arrow on the right. Give it a circle. What direction is it going? It's going down towards negative infinity. And that's how we play with end behavior. And so we're going to do that same thing here on number 16. We're going to get that typed in, kind of so we can get a little bit of an accurate picture of things here. Scooch this over a bit so we hopefully don't get glare. So we've got x. Again, if you're kind of playing with these for the first time or it's been a while, there's my button to get me up into the exponent. And then I hit my right arrow to get back down. Take a peek to see what it's supposed to look like here. All right. Maybe. There we go. So we'll try to get some points in here. And again, if your graph's not perfect, don't worry about it, but it should be kind of similar, at least when we're looking at it. So let's see here. Domain, I don't even have to look at the graph. I know what it's going to be. Range. Y values, bottom, forever down, to top, forever up. And then my end behavior, I always know I got one of each for my x's. So as we're going to the left, here's my left arrow. It's going down. Down is negative. As x goes to the right, find my right arrow. What direction is it going? It's going up towards positive infinity. And we get set with that. So again on these, just kind of take your time, think about what you're doing, roll through, not too bad. Now, let's try and calm some of you when we turn the page, if you hadn't looked through this before. Review. They're like, review? Wait a minute, we just started the semester. Right. But we got to keep some of this stuff in mind because things start to show back up. So, I'll show you momentarily what we're going to do to help out on some of this on the review. So back here on the back page, we've got 3 review problems from some first semester stuff. Okay, simplify each expression completely, write in standard form. When we have i's, our imaginary numbers, we can't have them in the denominator. So what we got to do is we multiply by what we called the complex conjugate. And again, what's that mean? It just means we're changing the sign of our I term. We're changing the sign in the middle. And so what we're going to do for each of these, to simplify them, is we're going to kind of start doing some boxes or some foiling again. So just like we were doing before on the front when we were multiplying things out, we multiply coefficients. And we add exponents. But what we got to remember when we're dealing with I is I squared equals -1. So this bottom right-hand corner isn't really 2i squared. It's 2 times -1, which is -2. Because when I go to simplify it then, 8 minus 2 is 6. -4 and -4 do not cancel. If I owe somebody $4 and I borrow 4 more, that'd be cool if they said I owed them 0. I'd go borrow money from them a lot. -4 and -4 would be -8i. I in the numerator is fine. And then I FOIL or box one more time in the denominator. Same rules. Multiply my coefficients. If I have an I squared term, which you will, -1 times -1 is +1. 4 plus 1 is 5. And 2i and -2i cancel. No i's in the denominator. I'm a happy camper. And we're good to go. Solving, straightforward. We've been doing this since like the first week of school. Get your x squared term by itself. How do I do that? I do the opposite of minusing 8. And then I'm still working on getting x squared alone. What am I doing? I'm multiplying it by -3, so I do the opposite. Now, when I get to here, a couple of things are going to start to happen. The opposite of squaring is to take the square root, which is going to cause a couple of things to happen. First, the squared there tells me there's 2 answers. So when I take the square root, I'm going to plus minus. I've also got to keep a couple of other things in mind. When there's a negative under the radical, okay? If I attempt to do the square root of -12, error, non-real answer. Oh, yeah. I got to pull an I out to make what's underneath positive, where I can actually break it down, which causes us our next possible issue. Are we going to write down 3.46? We're going to break this sucker down. So remember, I need to find 2 numbers that multiply to 12. One of them has to be a perfect square that we can get out of radical jail. Okay, 4 and 3. Because the square root of 4 is perfect, it gets out of radical jail with a new identity. 3, however, is still going to act irrationally, so it must stay in radical jail. So here's what I got to remember. I is out of there, and 2 is out of there with it. So 2 and I outside of radical jail. 3 still in. Lots of details. And finally, write the equation of the circle in standard form by completing the square twice. And identify the center and radius. You're like, oh dear. This is when you had the flashback to me doing the rap, sing, whatever that craziness was. So remember on these, we're going to group together our x's and y's. So when I group my x's, I'm going to put a blank with them. When I group my y's, I'm going to put a blank with them. And my -45 gets both of those blanks on its side. Because whatever I do to one side, I got to do to other to keep my balance. So you're like, okay, so what goes in the blank? All right, here goes the bad retro Harty sing. Okay, got to find b, my number in front of x. We're going to half b. We're going to square half b. We're going to add it here. We're going to add it there. And you got to hear me one more time, then you've survived. You got to take your b. You got to have b. We got to square half b. We got to add it here. Add it there. And then the actual step of getting into the standard form is the easy part. We've done the hard part. Because remember, to get the binomial form, you just take your b divided by 2 number, the number in parentheses. And we do that for the x. And we do that for the y. And over here, we just add them up. There, ladies and gentlemen, is your standard form of a circle. My center, remember, is the opposite of h, the opposite of k, and my radius is the square root of my answer. Now, to try and put some of you at ease, maybe that either were kind of not really present first semester, or literally weren't here first semester, here's what I'm doing to try and help with some of the reviews, and I'm going to even put a little bonus in with this. What I've done, okay, with what we're doing on the website here, if you go to Thursday where we're at, here's the actual preview if you need another one, okay, the video will be up here momentarily. I'm putting up extra help videos on 17 through 19, so for those of you that weren't here, if 18 looked like, ooh, that's hard, here's the lesson with some more examples on how to do the breakdowns and stuff. Completing the square with circles. Here's a video, shows a couple more, and I'm working on getting 17 up. I'll have it up by the end of the day. But here's the other thing I'm going to be nice about. Because I just feel nice at the start of the semester. You can select one of these 3 problems tomorrow on your quiz to be extra credit. So you're like, oh, so that means I might not have to look at one of these, or I can get extra points out of the deal. But you'll have to just tell me tomorrow. You'll circle 17, 18, or 19 and say, okay, this is my extra credit question. It's not counting against me. Might even count for me. That's good. Sure, you can do all of them. Yeah, you can do all of them, and then you'll just get extra credit on the extra one. Or if there's one of them, you're like, oh my gosh, this completing the square I don't get. Well, I'm just going to make 19 the extra credit, and then I don't have to do it. I'm just going to do these 2. So if you want to push ahead, you can get some extra. One of them will be extra credit. You pick. But if you mess up, then you got some backup. Okay? So that is what